Objective number 7 is all about using an activity series, either metal or halogen activity series, to be able to predict if a reaction will occur. And these are going to be single replacement reactions only. Double replacement reactions take a little more knowledge than we have right now to predict. But with the single replacement reaction, you use the same technique each time. What you need to do is look at your reaction and see on the reactant side which is the free element or the unreacted element. So if I look at my first one, aluminum is my unreacted element, and then I have to realize it's a metal, so I need to use the metal activity series, and it needs to replace the metal in the compound. So the question is, can aluminum replace iron when iron's in the compound? So if I find aluminum here, and I see iron is less reactive or further down, I know this reaction will occur. So I would expect to see AlCl3 form because aluminum is also a +3, and iron become the single element or the single atom out there. MgSO4 plus Cu. Copper is my metal looking to replace the metal in the compound, which is magnesium. So I have to look and see, is copper more reactive than magnesium? And the answer is no, so this would not react. With my third example, I've got fluorine and Hbr. Well, fluorine is a nonmetal. Hydrogen and bromine are both nonmetals, but fluorine, remember, has a -1, so it has to replace the nonmetal with the same kind of oxidation state. Bromine has a -1 oxidation state. So when I look, I need to see, is fluorine more reactive than bromine? And it is. So I would expect this to form HF and Br2. And if I go ahead and balance it, I would put a 2 here, a 2 here, for the balanced equation. I2 and HCl is going to be similar. Iodine is looking to bump chlorine off. If I look, iodine is not more reactive than chlorine, so this will not happen. And the last one, if I have Mg and HCl, magnesium is a metal. Neither of these are a metal, but remember, hydrogen acts like a metal because it has that +1 oxidation number. So it gives it something in common with the metals. And so the question is magnesium more reactive than hydrogen? And here's hydrogen, and here's magnesium, and you see that many metals are actually more reactive than hydrogen, which is why many metals react in acids like HCl. So yes, this would react, and I would have MgCl2 plus the hydrogen gas, and I would balance it like so. So that's how you use the activity series to predict if reactions will occur or not.